Ladies and gentlemen, welcome back to the fourth video in the Maya Python auto rigging tutorial series, which is a mouthful to say the least. Today I want to do a couple of things. I want to show you the code that I've been working on since I've updated the tool quite a lot, and I want to show you, what I've done, how I've done it, and why I've done it. And the second part is that I want to get started on the IK, be it the RP solvers in the arms and legs, but also the spine. So we're going to make a curve, we're going to add clusters to it, and we're going to do the whole shebang that you would need for a spine rig. So I just want to show you what I've done so far. So I've added quite a lot. This is my auto-rigger class, which I've turned into a class because it looks a little bit prettier. I just want to show you what I've done. I'm just going to start up everything. So I've made a custom shelf button. I'll show you why and how I've done it. So I mainly just changed the UI. The prefix, which doesn't work yet because I had some issues with parsing through strings to different classes, but that's all different story. So I can make the base locators that we've done before. So this is nothing new. It's the same thing we've done before. But now I can also add these secondary locators. So I can create the foot roll, the reverse foot roll, and I can add a forearm twist if I want to, and I'll show you how I've done it. And then, of course, I can make the joints. So I can create them, and I can set the orientation. I'm going to explain that as well. And create IK, which doesn't work yet. Well, I've just made the button in advance, so it's a little bit easier to get started. Okay, so I've made a button here, right? I'll show you why. So I turned my auto-rigger into a class on its own. And when you make a class in Python, the first thing it will need is a def underscore init underscore self. For those who are familiar with languages like C++, Java, or C#, this is similar to having a constructor in your code. That's the same thing. So when you call the class, in this case auto-rigger, when you call the class auto-rigger, it will look for a function or def called init. If you don't have it, it's not going to do anything. And everything inside that function will get executed. So in this case, I only execute the build UI. So, but you can also set variables. You can also set, you can call different functions if you want to. In this case, I just call the build UI one. And in here, it's the same thing that I've done before, right? But I just added it a little bit, and I created separators. In this case, ST stands for style with none. Now, I've also put this code on GitHub, which you can find a link in the description of this video. So if you want to have a look at the code, how I've done it, then you can just see for yourself. It's a little bit easier. So in the button over here, I can edit it. You can say here that I import the class, in this case auto-rigger as AR. I make sure that I reload it, so I always get the latest version. And then I just call the auto-rigger. In this case, I call the class itself, and I don't call a function, but I call the class. So I call the class auto-rigger. By calling it again, it will look for the init function, and then it will execute everything in that function itself. So the locators, same thing as we've done before. Nothing changed really. Actually, nothing changed to this one. But I've added the secondary locators, and I kind of want to add a third layer of locators. For example, in the stomach area. And that you can add joints to help preserve the volume. For example, when the character is benching forward, I kind of want to have that so you can preserve the volume. You might do it as well for the shoulder area, but that's a whole different thing. The foot wall, it's similar as done before, right? It's just the basics in there, nothing really complicated. However, though, the forearm twist is a little bit more complicated. I'll show you why. Let's start paint because it's beautiful. Yeah, for example, right, we have the elbow over here, and then we have the wrist over here, right? So, and then I want to place locators based on the distance between those 2 points, right? So, say for example, I want to add 3 joints, then I need to add a joint here, and I need to add a joint here. Beautiful drawings are. But in order to do this, I first need to know the distance between the wrist and the elbow, right? So this is the elbow and this is the wrist. Sorry for my amazing looking art. Okay, so that's how I do this here, right? So I just get the distance between them. So in this case, I get the Y position, and I just check the Y position of the wrist minus Y position of the elbow. And then you get the distance in between those 2 points. Same for the X and same for the Z direction. So I get it from all vectors. Okay. Next up would be actually placing it, right? So I make a joint, in this case a locator, and I move it. So I first start at the elbow and then I offset it, right? So the reason why, I'm going to show you why I do this. So we get the, first we get the, I'm just getting rid of the beautiful art here. It's absolutely amazing. Beautiful. Here. This is why no one uses paint, but for this job it suits perfectly. Okay, so we get the position right over here, we get the position at the elbow, so we get this one over here. Then we kind of want to offset it, right? So then we add here the factor x, so the distance between those two objects, divided by the amount of joints that we want to add. And then again, we add another plus, right? So we just get the position here, then we're going to add the factor x, the distance, and divide by the amount. So we're going to add it, for example, here, the first one. Over there. Beautiful. Let's just grab a brush. Yeah. So we get it here. Then, if you have more than one locators to add, you need to add a secondary offset. That's what I'm doing here, right? So it's plus the, again, the distance divided by the amount times I in this case. So the first one, the first I will of course be 0, right? So it will just add the offset. So let's just, for example, say that the offset is 2, simple number. So it's x plus 2, and then again it adds the amount multiplied by I. So the first time will be 0, so it will just have this position over here. The second one, I will be 1, right? So you get the double offset over here, and then if you have more, you get more and more of the actual offset that you need. This is how I've done it. It might be a different solution for this as well, but this is how I've done it as well. And do the same thing for the Y position and the Z position. So it's the same math, you just offset it plus the offset multiplied by I in this case. I also say here the amount minus 1, because if you have 3 joints, 3 twist joints, you only need 2 locators, right? Because we already have one over here and we already have one over here, so I only need to add 2 in between, so then you get 3 joints, joint, and joint. So this is the logic behind this. Not overly complicated, but you need to know, you need to think in a certain mindset this as well. Now you also may have noticed though is that I can give colors to my locators, for example, here. This is a simple trick. Let's grab one, and then in the attribute editor, right, you have a display function. And in the display there's also a drawing override, so you can actually override the current way the object is being drawn in the viewport. First you need to enable it, and then you can set the actual color. So in this case you can set any color you want to, then it will have that color in the object. You can also set the RGB value if you want to. In this case I'm going to do that as well. The default it's set to index, right? And that means there is a predefined list of colors. So the first one is gray, then you get black. So 0, 1, 2, 3, 4, etc. Okay. The way I do this in the code, I'll show you as well. Let's do the second one first. I do it here, right? So I set the colors. I first enable the override by setting it to 1. Then I enable the override to RGB colors, so we use the RGB color. And then I set the actual color itself. So 111 in this case means white. You don't set to 100, which means red, etc. 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 For the locators though, I only set the RGB colors to 1, which will grab the index, and that will be the second color in the list. First one is gray, 0, then black one is 1. Therefore, I'll set this to 1. So that's what I've done so far in the locator area at least. Next step would be the joint. I'm going to make them again. Actually, I'm going to do this. So I created joints. Last time we got stuck at the hand. It actually made perfect sense the way why we got stuck, right? So we just started here with the wrist, and then we added a finger, and we kept on going here. Then we added a second finger. You can see here that everything is parented. It actually forms a chain, right? So we don't want to do that, so we need to do it differently. So we make the wrist, then we make a finger, then we deselect everything, and then we add a new joint. Okay, in code, it actually was similar like to this as well. So we'll get to the joint part here. I'm going to go to my fingers. So I first make sure that I deselect everything, right? So base dot select deselect is true. So we deselect everything. Then again we select the wrist, and then we start adding new joints to it. So the wrist will always be the parent of the newly created joint chain. So deselect it, select the wrist in this case, and then make new fingers. Same thing for the legs as well. So I first deselect everything, then I select the root joint, then make the new joint chain. Otherwise, in this case, if I don't do it like this, since my legs are done after the fingers, so you probably create something that it will take the last fingertip and then add a new joint to the leg. So the legs will be parented to the actual fingers, which is probably not that helpful. So which is why I make sure I deselect everything and then I add the actual, then select the actual root again and then make the new one. Same thing for the, pretty much everything the same, right? So for those who know rigging, you also know that the joint orientation is really important. Usually though, you do by yourself by going to select the joint and then that skeleton and orient joints. I've done it in code a little bit faster as well. So by default, right, when you grab a joint over here, for example, the joint orientation will be set to the world. So Y is up, X is to the right or left, and Z is forward or backward. That's fine for motion capture rigs, but in this case we're not doing motion capture, right? So we need to set our custom joint orientation. In this case, I just click it and X is pointing at the child, which is perfect what we want. So to do this in code, we just type literally one line. Well, in this case, I select the root joint. I say joint edit is true, channel is true, and then we set the OJ, which is orient joint, to XYZ, right? You can also use set YX, set XY, whatever makes you happy, but default value is XYZ, so that's what we're using it for. Super easy once you get the hang of it. Took me like half an hour to figure it out, so I'm going to save you that time. So just say this line orientates the joints to the way that we want to be. So let's get started on the actual IK handles. So I made a new file called create IK, and I created a function called IK handles. And in my joints, I already have a button there that says create IK handles. So again, I just imported the class. I make sure that I reload the class all the time. So get the latest version, and then I just call the function. So in this case, I don't want to make a menu or anything. I just want to click on a button and that it will make all the IK handles for us. So you can make them by just saying .IK handle, right? So based on IK in this case, IK handle, and then you can give it a name. So give it a name. Then you need to set the starting joint, which is XJ. Then you need to add end effector. Now this can be anything. You can also add an object for this, but in this case we want to use a joint. And then we need to set the solver, right? So you have, those who are familiar with rigging, you have the RP solver, you have the, stands for rotate plane solver, you have the single chain solver, and you have the spline. In this case, I'll just type it out. So RP solver, get this one. Note the capitals though, it's really annoying. I had solver as well for capital and then it crashes and you don't want it. So the IKSC solver, and then you also have the the IK spline solver. So these are the three options that you have. Now for arms and legs, we want to use the RP solver. For the inverse foot roll, we want to use the single chain solver, and for the spine, we want to use a spline solver, right? So let's just get started. Let's just start at the leg, at the arm, sorry. So we're gonna say base.IK handle. And then we need to set a name. You can use, I'll just type out a name, a little bit easier. In this case, I'm going to say IK left, not left, arm. That's the name of the object. So the starting joint, right? That will be, in this case, the upper arm. So what I'm going to do is I'm going to do a base.ls again. And then I'm going to select my left upper arm. And here's where things a little bit tricky. By default, when you use ls, it creates a list. Even though there's one object in it, it's still a list. So we need to make sure that we access the first object in that list, and that is in this case the actual arm itself. So by saying here square bracket 0, we make sure that we access the first object in the list. It's really annoying, but this is the way mine works. So same thing for the other object as well. So again, brick underscore, the end effector will still be the wrist. first object in the list 0. Therefore, the solver we are going to use the IKRP solver. That's it. This is how you do the IK handle. So this is a quick look. I'm going to compile it. So if it works fine, it works fine. Restart my menu, so I make sure that it actually functions properly, and then I'm going to create an IK and poof. There we are. And we have an IK, functioning IK handles. So, beautiful. Okay, let's get rid of all the locators, we don't need them anymore. So, we do the same thing now for the other side as well, so I'm just going to copy paste it. For the legs as well, so 4 times in total. This would be the IK arm, and then the right upper arm, and then the right wrist. This would be the left foot, and this is the right foot. And then here we'll start with the upper leg. And this will be the right upper leg. So, this would be right, left leg and arm leg. Okay, save it, compile it, see if it works. It should work though. With IK, there you go. So now I have all the IK handles set up, so I can grab one for the leg and then go down on it if I want to. So that should work properly. For some reason this one does not want to work. Awesome. Don't know why. This one works. This one looks fine. This one being a little bit of a dick, apparently. Doesn't really matter though. Let's get rid of all of them again. So, this is the weird. Let's get rid of the chunks for a second. A little differently, I'm going to grab these two and move a little forward. There. And create chunks. Okay. Then back. Beautiful. So this was the easy part. Next up would be the spine, but we need to do a couple of things. For a spine IK to work, we need to make a curve, right? So we need to make a custom curve. If we want to edit it in the future, we also need to have clusters on it, so those we can parent to a control object. So you can make a curve that's actually quite not that difficult. I'm going to add indentations over here. Okay, you can make a curve by just saying base on curve, right? That's going to make a curve. Then it will ask for a position, like this, and then it will ask for, well, since it's a list, right, we need to add multiple, like this. So in here, for every control vertex you want, you have to add brackets, right? In this case, it will create 4 points of that control of the curve. If you want to have 3, you only have 3 of those brackets, then you have 3 control vertices. Here's the issue though, we don't know how many spines we have in advance, so we need to make a function that we can create that will expand on how many spines we have. First, I'm just gonna show you real fast how this will work, right? So you get 1 on 1, for example, you have 52, and then you have 53. Of course, you can also give it a name if you want to. In this case, it would be n is something, right? This will make a curve with 3 control vertices. I'm just going to show you real fast. Transfer window, I'm going to create IK, and then we should have a curve somewhere. Find it. Or not. It didn't make the curve. Or because I didn't find it. That's weird. Am I that stupid? I don't think I am. Huh. It should have made the curve. Let's find it again. Or being an idiot, so. Yeah, guys. So this is the curve, and then we have 3 control vertices. We have one over here, and one over here. etc. Okay. You can also set the amount of degrees that you have in your curve. In this case, I only want to have one since I want it to be square-ish, if that makes sense. So degree 1 means that there is no smoothing of the actual angle of the curve itself, which is what I want. Okay, so this is how you do a curve. So let's now get into the actual gritty part of it. So we want to start at a root joint. In this case, I'm going to make a new variable, and then I'm going to get the form of our base.ls big root, right? Like this. So we want to make sure as well that we get the actual joint in there and not something very shaped. So that's joint. This again, Q is true. We want to get the translation is true, and we want to make sure it's in world space. Also true. Okay. This is the position of our root joint. Now we also want to get positions of all the spines, right? So we get all the spines. So again, based on ls rig spine asterisk type is joint. So we get all the spines, but this has everything in there. This has also the scaling of the object or rotation of the object, so it's useless. We only want to get the actual translation of it. So we need to make a for loop, and then we need to store it in a new variable. So we only get the position, right? So I'm going to make a new list. So I'm going to call this spine position, and then I'm going to make an empty array, right? And then we can actually append to that array when we need to. Again, I'm going to make a let's call this p in enumerate, so we can actually walk through the entire list spines. Okay, so then we can actually append to that list by saying append. I know, one about it. And then we can get the actual form again of the spines. In this case, it would be spines I. Then again, Q is true, T is true, and no space is true. Like this. So this will actually append new positions to our list. So this spine position will be filled by the amount of spines that we've added. In this case, it will be 4. Beautiful. Now, you can't make a for loop in a function or in a my command. So what we're going to do is that we're going to make an empty curve, which is the simple curve with one control vertex, which means that is the root joint, and then we're going to add new control vertices to that actual curve. So first I want to make an empty curve or a simple curve with just one control vertex. That will be again p is bracket bracket. In this case that will be the root position 0 and root position 1 and root position I can't type anymore, I'm sorry. Position 2. Oh. Okay, we're gonna give it a name as well, of course. That will be n is let's call this spine curve. And again, I set the degree to 1. Okay, let's just test it out real fast. So I'm gonna grab all my K's again. I'm gonna delete them. And window, create my K. Okay, we now have a single curve here. We have curve spine curve, but it only has one control vertex, right? Which is perfect, and it's on the location of our root joint. Perfect. Then we're gonna append to that curve. It follows the same loop. So I'm going to do the same thing again. Again, I'm going to make a for loop because I need to have a for loop. So for j, in this case, we're going to call this AP, or let's call it SP actually. And enumerate, and then again we do it now. This case on the spine position. For the amount of spines that we have stored in that list, we want to run this for loop several times. Again, paste our curve, and then we select our curve in this case, which is the spine curve. Then we say A equals true, which is append. Really annoying thing over here. I don't know what this is. Okay. So append is true, and then again we're gonna append new objects to it, and again P is same thing. It follows the same method as we done before. But in this case, we want to go a little bit hardcore. So the spine position, right? It's a two-dimensional array, which means that we grab it. So we get the spine position, the object in the list itself, so let's say 0, and then we have the x, y, z positions again. So we get 0, 0, or 0, 1 for the y position, 0, 2 for the z position. So what we need to do here is append it based like this. So we get the spine position, then bracket j, and then 0. So the first object in the list, and then the x position of that object. Again, spine position j, 1, and then spine position j, 2. Beautiful. Let's see if I got enough brackets. I think I have enough brackets over here. Let's have a quick look. Probably not great. I see that's fine. And we should have 4 vertices on every single, or 5 even, sorry. Perfect, not else, it's also, as you can see, 1 degree. So this is perfect, this is exactly what we want to have. Okay, delete everything again. Like this. So, when you're doing rigging on the spine, the way it is right now, we can't control the actual spine itself or the curve. So we need to add a deformer to it so we can actually move the control vertex of that spine, which can be done by adding a cluster to that control vertex. So that's exactly what I'm going to do. So first I'm going to grab all my CV points, or control vertex is CV. So based on ls again, and then we're going to grab the spine curve. Oh, I can't type, sorry. So spine curve, right? The object that we've made, the name of it. Dot CV, which means the dot control vertex, then 0, like this, right? So this will grab all the control vertices of that spine, and then we say FL is true. So, if you don't know what FL means, you can actually look. I think it's over here. FL is flatten, right? So it just gets the object name, nothing more. So, next one would be to add clusters to those control vertices. So again, I'm going to make a for loop because I want to go through all the control vertices. So again, in this case, I'm going to use k and then cv enumerate curve cv like this. Then I want to store them in a variable because I also want to parent them at some point. And then I'm going to say again, based on, in this case, cluster, right? So this will make a new cluster. Then cv, and then of course I want to give it a name again. So name is cluster plus the value of it. So cluster 0, 0, cluster 1, etc. So I'm going to convert my k value into a string. And then I'm going to add a underscore here. The reason why I do this, when it makes a cluster, then it will give it like a name and then handle, right? It will add handle to it by default. You can't change it, so it just adds handle. By adding the underscore, it just looks a little bit prettier. That's the only reason why I'm doing it. It just looks prettier in the outliner. So that's pretty much it. So this will make a cluster for it. Let's see if it runs. Quick look. We compile it. Hit quit IK, and then we have the spine, then we have the curves, right? So those curves can actually control the actual, those clusters can control the curve. But what we kind of want to have though is that right now they are not parented to anything, right? So ideally you do this manually. You have 4 is child 3, 3 is child 2, 2 is child 1, so 1 and 1 child 0. Like this. This will be the hierarchy. Now you grab all of them, you can actually see that it creates a curve when you bend them all together. This is what you want to have, right? For a spine, this is what you kind of want to have. This is what you want to achieve. But that means you also need to parent them, right? So the first cluster, we don't want to parent to anything because that should always be parented to the world. So I'm going to delete everything again. So we want to make sure that the first one is not parented. And after that, we want to parent it to the previous cluster made. So you can say here, for example, if k is greater than 0, so if k is 1 and higher, then we want to base on parent it. If you want to parent the cluster that we just made, so C, that's what you want to cluster it, well, cluster, again, then we say string k minus 1, so the previous cluster that we've made, plus underscore handle, since it will make a handle again of this. Let's start again real fast. Choice window, create IK. There we go. And then we have a nice hierarchy of the clusters as well. Perfect. This is what you want to have. Beautiful. Yeah. Let's get rid of these as well. The last step would be to create the actual IK for the spine. So I'll do it as well. Again, this is based on IK handle, same thing. But now we just need to add a one more attribute. So again, name, I'm going to call it IK spine. It's not joins, right? It's just the rig root. In this case, I want to do it a little dirtier. So there will be the rig spine 3. Ideally though, we will get this from the located from the outer record class itself, but for now I just want to do it like this, because I don't want to spend like half an hour figuring out why it's not working, so let's do it like this real fast. So then we get the IK spline solver, and then we need to feed in the actual curve, right? So what curve are we going to use for that spline solver, and that will be in this case spine curve, the name of the object that we've given here. And now in theory we should get perfect. Yep, there it is. Now we can actually twist it. We get a perfect spine. This is what you want to have, right? Although we can't move it yet. We can grab this one, but it doesn't do anything, right? Because this needs to be paired into something, otherwise it will not work. We can grab this curve here, but it will just fuck up everything. So. That's it for now. So next time we're gonna add all the controls to the to everything, and then finalize it hopefully, and then also gonna work on the more complex stuff. For example, the forearm twist and how to do that in code using Python. Because usually you do that through the node editor, but I want to automate everything, so we're gonna do this as well. So thank you for watching. And I'll see you again next time.